Hi folks, so welcome to this live coding of ray tracing and weekend in the programming language OCaml. If if you can hear me, then please just put something in the chat so that let me know you can hear me. And uh, this is book we will follow. The code base is in C++, and we will write the whole thing in OCaml instead. So let's open Emacs. That will be the text editor of choice of me writing OCaml. So one disclaimer is I like Emacs. I like retracing and I like OCaml, but I am expert of none of them. So if I do something stupid, just point it out in the chat. See if I have any comments in the chat. Not yet. Okay. Open a shell. Go to the OCaml folder. I will just put my stuff here. Now let's create a new project. Init, okay. So Dawn is the kind of not package manager, the build system we will use to build OCaml project. It is quite nice. Not certainly not as good as, like, for example, Cargo of Rust, but it's way better than, for example, pip, virtual env, stuff like that. Yeah, so I'm glad OCaml have this great tool we can use. It's called OCaml PT. That stands for OCaml Path Tracer. So you can see when we run this init command, the Dawn generates a bunch of folders for us, bin, lib, and test. Oh, in the chat? Yet. Yeah, I don't know even know if anyone is watching this. So yeah, let's continue. You see the lib. Only Dawn. Well, we don't need lib yet. I will just go to the. Okay, we have main ML in the binary folder. I will pull into libraries. That's not here, probably in the library. So base library is kind of an alternative to the OCaml standard library, because OCaml standard library just don't contain enough thing I want. And this base library is like, so this company called Jane Street provide that, and a lot of people in your OCaml community use that because it's just it provides just what you will expect in a standard library instead of OCaml standard library is like minimum stuff. So we have base, and std.io is just for some additional output stuff. Now we have everything. We can go back to our binary folder main, and yeah, there's seriously no one in the chat yet. I'm live, right? Okay, I guess I will not check that. I would just assume I'm live now, and yeah. So instead of print hello world, we can print something else. I guess we'll first try this in build and we can run it. Read for some project with that file. Yes. That's not a problem. Oh, what? Okay. So we can run this thing. That's good enough for me. And let's start from this retracing a weekend book. The first thing we wanted to do is output some image. And we copy paste this C++ code, because why not? And then just try to write OCaml in it. We have an image size of 200 times 100. And forget where printf is, probably in the base. Oh. If, oh, I think it's instead IO. Sorry. Printf history width height and that's it. So the file formatting we are output is called what's called ppm. It's, as you can see, it's just plain text, so it's really easy to write output because then we don't need to pull out any like image libraries. That's annoying. Just not using it yet. Looks nice. Now, how to deal with this for loop? So first, OCaml is expression based, so if we want to have some pure set effect and then continue to do stuff, we need to like make it something like this to just catch the result, which is the unit in a dummy variable we will never use, and then just continue. And for this for loop, the way to mimic for loop in functional programming, like, is to using some kind of higher order functions, and we need some not lazy sequence, because if it's eager, then we just generated a sequence like from 0 to some number and we just allocate for no reason. Instead we need a lazy sequence. I think base have that sequence library built in. Is it called sequence or range? No, sequence Yep. Oh, yeah, the sequence dot range is what I want. Oh, let sequence dot range. Sequence dot range. Stride is optional. This is start and stop. So for J, we start from then we need stride of -1. It's -1 to 0. We need to map this thing and see what the result looks like. Okay. Later, it takes a sequence as a first argument, not a second one. So I cannot use this pipe syntax. Oh, I can because 6. Yeah, that's a named argument. So we take J, which is printed. Expect time. I think it's this negative. Sorry. So that's when you know too many programming languages, so you can never be sure what you are doing is right or wrong, because you're constantly confused by the syntax. It's not what I want. 99 to 1, not 0. An integer from start I to stop I. That is need to set the stop to inclusive, I think. It's lowercase, and now it's to 0. 99 to 0, I think that's what we want. Okay, so now we have y, we need x, sequence addition products, then we have to Cartesian product of the two of the ranges 0 to width is inclusive. I think it's okay just to make it look like this. Let me see if this is right. Like so. Okay, let's continue. Then we want to generate RGB colors from this. Float of int. So this is one annoying thing about OCaml is it doesn't support any kind of ad hoc polymorphism. It do support define arbitrary operator though, but like this operator, this divide operator is already for int. So for floating point number, we need to do something like this. This is really annoying, but what you can do about that? Float dot of int instead, okay? Now we need to convert it back into integers. Int we have everything we want. Float percent expression was yes. Oh, yeah, that's what I said. This operator thing is really annoying because it's really easy to forget. Int f it would be. Oh. You need this. What am I doing? What is this? Yeah, I think we're fine. So now it's time to actually output this into a file instead of doing just standard output. So to open a file, we need to base output. We open the base out channel rate. Printf. No chat. Fine. Guess no one is watching that. Alt channel dot fprintf file. Nice. Here is that of printf. We don't need head. Just to say OCaml image. Looks right. Yeah, it looks right. It should be right. Adding a progress indicator. That's not here where did this work, but I guess we will not add that because currently our progress is so fast we don't even need this kind of progress indicator. So let's just continue to disable this kind of notification. I would do that later. So we now output a file which looks right. So it's time to create a vector class. So this can be a bit annoying doing numerical stuff in OCaml because, as I said, no ad hoc polymorphism means no support for like operator overloading, for example. Okay, so let's create something really quick. mlp.ml. But we will not put stuff here, but instead we have a vx3.ml and we will put our stuff here. And in this file we will just re-export vx3. And keep this open. Over here we go to a test because we probably want to do some tests. Test name OCaml. OUnit. So OUnit is the unit test library in OCaml. but I never can remember its syntax because it's kind of weird DSL. So we will do some quick copy and paste. Not some, obviously. See if this thing works. Font value of unit 2. Maybe I need to compile it again. I think it's libraries. So we must put something into that. Wait, what? That's okay. So we correctly have some tests set up. So let's say we do X3 creation. Let v equal to x3 dot grades 1, 2, 3. And what we want is v dot x is equal to 1, v dot etc etc. Yeah. So you can see here I'm following a test-driven approach here. I first create a test and then implement them. We don't need that. Let create xyz equal to xyz. And we do need a type for the module. So the T is a conventional name for OCaml, and the type is kind of represented by the module. So in this case, our module called vex3. So this type is like our type is vex3. So we will just call it T. That means that this module have this type T, and it's this module contains this type and a bunch of functions of that type. So you can think of it kind of as an object-oriented class. It's kind of similarly, we have one type and a bunch of functions related to it. Unbounded module vex3, of course. Wait, why so this is still unbounded? We have a library, right? Library name OCaml PT. So in here, library, a different name for the test. Good, no, just not equal because I copy and pasted stuff. Okay, so that looks fine. So next step is to create helper functions. Even though OCaml do not have any kind of ad hoc polymorphism, I do want to use the infix syntax because otherwise it's just too annoying. So do whatever. We cannot do plus here because this operator is already used, so the only choice is to use something weird. Let's do this, whatever. And we need to make sure what we created so put some operator in parentheses is the OCaml way of creating infix operators. Colon now is equal. I think it's equal. Of course, I forgot about this. And this is I don't understand why the syntax highlighting is just confused about. It shouldn't be this way, but let's see if it can get fixed automatically later. That so the other vector functions are kind of mechanical, like the first one. One -2, -2. Of course, this, which is very annoying, but that's just OCaml for you. We can a vector can multiply by a scalar. That's what we are doing here. Going on here. What is going on here? This is fine, but this is not. Seriously? That's some weird syntactic issue. That will be ugly. If anyone is on the chat, no. I can't do this. Okay. I can't do this. It can be annoying later. Two. 3, 4, 6. Good. Divide. Should be able to do divide, right? Shouldn't be the same kind of issue. 0.5, 1.5. May not be the most optimal way of doing stuff. Of course. The expression have type T, but back to float. Oh. Looks good. I promise you it will not take that long for odd vector. We need dot product and we need length, that's it. Basically. Two plus 8 plus 15, 25. want value back. Ah. Right. We need length first to length square. We need length of the two things. Length square is just dot product of the length. Length square of 1 is 1 times 1 plus 4 plus 9 and 14. Oh. Okay, and finally length. Okay. Now we kind of have everything we want in a vector. Book have more, and the book has this kind of mutation functions, index accessors, negate. I think we need negate. So let's someone want to write an easy parser, I think, and then they make negative not a literal but an operator. As a result, then we need to like parentheses are negative. That's really annoying, I should say. But yeah. Gate. Good. We're done with vector. We will have a minute break and then let's continue. Hope someone copy in the chat. change my camera setting somewhat. I'm back. And let's continue writing a retracer in OCaml. We have level vector. Oh, cross product and unit vector. That certainly can be useful. Add those. So sorry about that. Sorry about because the whole string is not like prepared. It's live coding, so you can see this kind of going back and forth stuff. We follow their name convention, so I can copy and paste more without really use my brain. X, Y, X. Test cross product. Don't know what's the cross product of that. Oh, calculator. 2, 3, 2, 4, 5. Let's go. -2, 1, and 0. I will believe you. Ah. Good. So union vector, maybe let's call it normalize, because like normalizer vectors get its unit vector version. I haven't even tested. Two, three. On it divide by root of 14. Good. Now I can see we are officially done with vector. If we really miss something, then we can always go back and add them. So next class we want to write is array, not class, module, but because in ML languages like standard ML or OCaml, code are organized in different modules, not in like classes or files. Well, in OCaml, one file is basically a module, at least not for interface file, one for like one ML file is a module, and we can add additional modules, nested modules, like with this kind of module keyword. Let's do array. Array have an origin, which will represent them as a vector array. I can have another point module, but that means I need to duplicate a bunch of code. The type system becomes stronger. Like, for example, like you cannot add 2 points. It doesn't make sense, but it's just like I need to do additional work to make it work. So we stick with everything is a vector approach used by a lot of computer graphics programs. Not vector, it's vector.t. As I said before, vector is a module, .t is the actual type. Same as here, array is a module and array.t is this record type that contain origin and direction. And we still need 2 functions, but I will just test one of them. The other one will be tested implicitly with this test. Array, I will array equal to array.grade of v1, and the direction will be 0, 0, 1, 0, 0. As I said, I will only test one of function called add. So the idea is array at some position, like it's like array is a parameterized function. Think about it. Array, you can think array as a function that takes a number in and then returns your origin vector plus t times your direction vector. And so basically it's a function. If we know origin, we know direction, we can get get a point as a result from an arbitrary number t. Like if this is origin when t is 0, we will get origin. When t is 1, we get origin plus direction. When t is 2, we get origin plus direction twice, etc., etc. Array. Let's do something fun with pipe operator. I like pipe operator. Some folks said it makes my code unreadable, but I think it's exactly opposite. So I will use it a lot in this code. Like this, and let's do via Viva. Like that. Notice we use t again here. That means, OCaml, like in a lot of other languages, type and values are in totally different namespace, and you can have the same type name and the value name, and they will not conflict. Because traditionally, we call this parameter t. Just like if we look at this ray tracing in a weekend book, yeah, they call it t, so that's what we will use. Let's make this a little bit more explicit. At t, also we need array. We can destructure that, and this t is of course the type, not the value. So, and we return vector. So makes this function parameter more explicit. I think I have two advantages. One is it makes the code more readable. Two is it makes the auto completion works nicer. Direction and t. Font value recreate. Yeah, we haven't have this create function. Create will just take an origin direction and create origin direction with this record. Yeah, nice. And we're done with ray. What's the next? The next step is to do some ray generation in this code, so we can get a screen of like different ray. We will have different value on the screen. This recolor function is basically if we know ray what is a color. As a result, we will get the normal of the direction. This is a lerp. I think I need to mix this actually in that vector module of on dynamically loaded library. I will ignore that. I don't know what that means. This is definitely a linear interpolation, so let's put a hotfix on this vec3 class. Use a function that actually have two. If we have linear interpolation of v1, v2 at 0.5, then we should have 1.5, 3, and 4. Copy and paste all this mess to here. And in here we can just we don't even need to open vec3 anymore. It's okay, why we cannot do lerp? It's what's changed on the below part on the image gen, we have those four vectors for different for different. We can see it as cameras parameters. Like they are used to generate cameras. On the chat. Okay, I will just ignore the chat at this point. Because no one is watching anyway. No point to like check the chat. But I guess people will watch it afterward. We generate ray for each points on the screen. Oh, we still need open Vec3 then. Don't want to open too many modules, but if I want to use the operators, then I must. We need UV, which is... Where does UV come from? Is J over way. Wait, what? U is J over width. U is I over width, sorry. U is really just our previous R. Which makes sense. Don't need all those stuff anyway. And we have array. Our color will be ray color of ray. And still run a test. We can execute OCaml PT, and yeah, we get this like nice sky-like image, which is exactly what's on this book. And before we continue, I think I will do one little refactoring. That color 255 from float. Make this float to int conversion a little bit nicer. Not that much because our function name is long, but no reason to duplicate the same logic 3 times. Good. Now let's talk about ray sphere intersection. So that's probably the last step we'll do today, this ray sphere intersection, because well, if we want to do some ray tracing, at least we need to draw a sphere on the screen today, right? And let's say we have a sphere and a ray. If a ray likes, let's return to another color. If a ray is like this, then we know there are no intersection at all. In this case, we should just return the background color. If I have a ray like this, then we know it's intersect at this point. If a ray is like this, we know it's intersect at the first point, and we need to ignore the second point. Also, if I have a ray like this, it's just intersect here. So the thing is, we can have this from this distance from this ray to the closest distance from ray to the center of the circle, center of the sphere. If this distance is less than the radius, then we know the ray intersects with the sphere somewhere. If this distance is greater than the radius of the ray, then we know then nothing intersects. We can just ignore this ray. And after that, we can get those two roots. One is here for this one. The other one is here. But for this one, since our ray starting from here, when we calculate this root, it will be negative, and we will ignore negative roots and only count positive ones. That's basically the whole process. The math is not that complicated. Don't like how this is going this way. Let's just create a sphere module for now, and sphere have an origin, center I should say, and a radius. I'm not doing any polymorphism here for now. Later we will definitely do, but then polymorphism is more complicated, so it's not the topic today. When we have at least 2 shapes, then we must do polymorphism. And we have this function. That have a sphere, so have a ray. Notice my argument order is opposite from the C++ version. Ray is at first, and then this then the sphere is at second. So this way is like put the main data structure at the end of the argument list is a good way to do like in ML type languages, because for currying and also for pipe operator, you need to consider like the frequency of operands. Like hit curry with R is more useful than hit curry with S. What am I doing? If this kind of formula looks familiar, then you're right. This is quadratic equation, and yeah, I don't know what else to say. It's like you to know high school algebras have a lot of uses in like computer graphics work. Right here. Oh. So currently our hit function just returns a boolean that if it's true then we hit something, if it's false then we don't. Later we will definitely refactor it into return an option because we want something more complicated. Then in here, in the recolor, we say like let's be we can kind of see the pattern of OCaml here. It's like for each module we have a central type, we have this kind of construction function and a bunch of other functions. So if it's in object-oriented language, this whole thing will be a class, basically. Just the same kind of stuff. Chat. Create center. -5, 0.5, and Do I do. And why it's red? I guess why it's red? All this confused here. Don't know what's going on. Sphere heat. Spray and sphere. If we hit, then we do something else. We display the background color. If it's hit, I think in the book we just create a single color or something. Let's do that. Let's ignore that. And yeah, we have a sphere. We didn't do any test for sphere, so let's fix that. If our sphere is at 0, 0, -1, then if we have a ray that start at origin, and go negative, then it should intersect with the sphere. I don't know if I close this file and open it, this problem will be fixed. It's really annoying. Let's close the file and open again. And no. Okay. More tests. 2. If we just have a array like ridiculously odd, but not ridiculous, just a little bit off the odd side of, then it will not intersect with anything. Yeah. Okay. No, this is good, but the problem is when we need more data, we need to know some, like, for example, surface normal. That's the thing we want to know. The second is we haven't addressed this case yet. Like, we have 2 points because currently we don't even calculate the root, so we don't know the root is negative or positive. So know this. can simplify it. Happy. Sure. Probably good for performance and also makes the code a little bit cleaner. But this is not discriminant now. Doesn't matter. It's 1/4 of discriminant basically. And I think this version is what we want. If discriminant is greater than 0, we calculate the two roots. This is the small root, and then we see if it's small enough. And if it is not, if it's less than 0, sorry, if it's less than 0, then we need to find if the bigger root is okay. And of course, we have that case of both roots are negative, which I didn't show. Like if we have a ray starting from here and go this way, and in this case, both roots should be ignored. So now we need a structure or record, I should say. Its record. I will refactor this later to move it outside, but it definitely doesn't belong to the sphere module, but I will just leave it here for now. Now our function should, instead of return a boolean, we return option of hit record. So this syntax can be a bit surprising. For people coming from other languages, but that's the syntax of generic in standard ML or in OCaml. If you come from like more modern languages, then you may be more familiar with syntax like this, or like this, or like this. Just different style of parentheses, but the idea is the same. And OCaml is like this. And this is this is just kind of a classic tricks to say like throw exception at here because I haven't implemented it yet. This is useful for developing in the expression-based language. Shouldn't call this thing. That's a really bad name. But yeah, this is more like a temporary, don't have a good name for it, so we just keep with the book. This is smaller t. Instead of calling it temp, I will give it a little bit better name. For tmax and tmin, which we will just ignore for now. Max is equal to max float. Yeah. means 0. If our T1 is inside this from min to max range, then we know T1 is good. So we returned hit record of T is T1, P is P3, P later, so this almost so this normal always point outwards to the sphere because like this is the intersection point minus the center, so we get a vector like always like point this direction, this direction, this direction, etc. It's always pointing outwards. And yeah, what's wrong here? Because I use R. Float? Normal is not a float. Yeah, normal is a Vx3T. Okay. Should be good now. And of course for here we need, instead of sphere, we need to use this is like something. It is 0.5, right? Sorry. It should be like this. N should be the opposite of P. Normal. Unbounded record. Not equal. Like this. Not equal. We don't have a print function. The problem is even know where is it. Then the chat, no, so sad. Hmm. Yeah, I should have print function, but didn't. That's the problem. I think it's just this test is wrong. Our code is right, so I'll just ignore this. I'll figure it out later. It looks a little bit better. Also for this part, similar stuff. Except we have T2 plus I think we're good now. If you add more tests later before I push this into GitHub, but not in the screen. So I think in the book, now we just explicitly show the normal. Yeah, like this. It's like if we hit and not use if statement anymore because we are returning an option. Hit record. None. It's none. Just doing this. If it's none. Oh. Looks good enough. Let's add something to this one. This whole thing is a side effect, and after that, and down. Just down. now. Now we actually do something with the heat record. We want to explicitly show the normal of the vector, not vector of the sphere. This normal can be negative, so we need to do something like divide the whole thing by 2. Yeah, now we have a sphere that's on the screen that shows the normal direction of the sphere. So I think that's all thing I want to implement today. Let's just do some quick refactoring, make this code nicer. So here definitely we have a repeated logic. Heat record from T. But we still need some stuff from this function. Let's make it a local function. Heat record from T. This thing should still return a heat record optional. So if T is I don't have the else yet. This is none. Unused, of course. Then in here we have, when we have P1, we can see heat record from P1. Do I have does this option have monad arrow cases? I think it definitely have a monad for the happy path, but I don't know if it have monad for the arrow case. So yeah, I will look it up. Maybe let's just look it up now to see. Something like map some with This is not what I want. It seems only have a monad that maps the happy path, so let's not do it now. Some it's then some if it's now then don't even need to do another match, we just hit trigger from T2 E2 then let looks decent for me. I really hope they do have a monad for this. I will look it up again. If there's something nicer to do than pattern match this way. And before I upload, I will figure out what I did wrong in the test. I think I just get the number wrong, but just I need to calculate it again. And that's it. That's what I will show you today, how to implement ray tracing in OCaml. Thank you for watching. And yeah.